want to be getting into the 5s and the 6s. Don't even want to go there. A couple different kinds. You got hydroxide, calcium chloride. You know, hydroxide is the kalkwasser. Everybody knows kalkwasser. Drip, drip, drip. Only want to drip that. If you're doing calc, you only want to drip it. If you're just mixing it and dumping it, you're going to have issues with sedimentation. You're going to have issues with things burning up. However, both hydroxide and chloride are going to convert dissolved CO2, carbon dioxide, which is dissolved into the water column from the atmosphere, and vice versa. So the carbon dioxide is coming from the atmosphere into the water, and then it's also being released back into the atmosphere. Okay, so the conversion is what we're going to look at, because the calcium is going to convert into bicarbonate and carbonate ions. I know this is going to start to get a little crazy. Just stay with me. Some of you guys know this stuff, but some of this I didn't even know until last night and this morning. So calcium naturally occurs in the ocean at about 410. We want to keep it high 300s to mid 4s. In order to do that, we have to dose. You're not going to get that just out of your salt. So what are we going to dose? We're going to dose hydroxide. We're going to dose chlorides. Everyone has their own preference. I'm not going to tell you which one to use. Pros and cons. You can use them both, but you want to use them effectively and how they're recommended to use. Did you get through that book?
Oh yeah.
Did you?
Yeah.
Good grief! You must have been in that. You just got it a week ago.
Yeah, but I had it at the library.
Oh, okay. You know, Patrick, that's where it went. He checked it out because we looked. Because I was gonna get it to show everyone about that book. Man, I was gonna call you two to bring it, but I forgot, man. There's a book, Marine Chemistry. It's got the trigger on the front of it, and that's gonna be the one that's gonna really, it's gonna back up all this information we're gonna go over. Let me get a drink. All right, so calcium's gonna convert the carbon dioxide that's present in the atmosphere, that's being dissolved into the water column, into bicarbonates and carbonate ions. Okay, so that's the conversion that's so important, is converting the calcium to the bicarbonate and carbonate, because the carbonate is the base for all rock structure, calcareous, skeletal growth, all that. That's the one. So the conversion is what's important there. Okay, calcium carbonate I went over. That's the main component of all skeletal composition, shells, corals, invertebrate, exoskeleton, all that. That's the main deal there. That's the main component, is the calcium carbonate. I really should probably have made some of this to pass out, but we're gonna take these kind of cliff notes, if you will, and Tyler did it last week. We'll retype it up a little better than this and put it in a folder for you guys to come and grab next week or something, whenever you're back in, whenever you come back in, so that you can go over it. All this stuff's online too. Reef Keeping Magazine. I mean, you can punch in, you can Google in, you know, conversion of calcium to carbonate, you know, any of that. You can just Google stuff in. You're gonna find all kind of stuff. All right, this one I gotta read. Coral tissue brings the bicarbonate and calcium from the water column. So the tissue's drawing this stuff in. It's drawing these bicarbonates and calciums together from the water column. Now during this particular biological process, which is an acidic process, calcium and carbonate are bound together to form calcium carbonate. That's the conversion, where it's collecting both of them, bringing it in, and making the calcium carbonate, which is the base for all this skeletal growth, all the hard corals and LPS corals. Soft corals don't use as much. I don't want to steer you wrong. The soft corals aren't really in this. They're here, but not as much as with the skeletal based corals. All right. So the calcium and the carbonate bound together to form calcium carbonate, that is then deposited to form the exoskeleton of the coral. So we've got this conversion again. It's always occurring. It's always happening. You know, as long as all these things are present. So for this process and this conversion to happen, calcium is one of the main ones that has to be present. We haven't even got to the mag, the strontium, and the other ones yet, but they all have to be present. I'm just touching calcium because they're, that's the big one. So that's what forms the exoskeleton. The hydrogen ion is then pumped back out of the coral tissue, back out, and it's released back out. Then after that it's formed its skeleton, and it pumps out the excess. So that excess hydrogen ion is gone now. This is going to get a little on pH, which I still have. I'm going to hit that too. Low pH. Everyone knows low pH is acidic. When you have that low pH, the coral has to exert more energy to get rid of that hydrogen. So when we have these low pH, it's affecting the fish, yeah, but it's definitely affecting the coral as well because they have to work harder to process and complete this conversion. All right, I think that's pretty much going to touch that. All right, so we're good on how the calcium's converted. Bicarbonate and carbonate. Carbonate being that's the foundation. Cool deal. Is anybody dripping calc? Dripping calc? Yeah, a few people dripping calc. Got your own method, 5-gallon bucket, drip chamber, whatever. Not many though. Now this is it's the kit. I mean, kalkwasser, really, calc is calc, man. If it's a kalkwasser powder, it's pretty much all the same. I mean, what is it, a teaspoon per whatever, a teaspoon per gallon or something. Two teaspoons per gallon, I think is what it is, in a top off only. Is it 2 teaspoons? I think it's 2 teaspoons. 2 teaspoons. Mari, Patrick? Patrick's my mentor on a lot of this stuff, so catch me glancing over at him, he's gonna be going, or yeah, man. All right. So not many people doing calc. What are we doing? Liquids, powders, pellets, chopping marin. I mean, are we all dosing calcium, or are we just doing water changes? Dosing. Pretty much everybody's dosing. Trying to catch eye contact.
All right. You get the proper amount of calcium out of the seawater.
The seawater, you're not gonna. We've done a lot of tests on it.
That 8-gallon tank, and
yeah.
It's too hard to measure small amounts of calcium.
Yep, I understand. It is because when you're on an 8-gallon, the measurements that are on the back of these containers don't even pertain. Right. I mean, you'd have to sit down and do the breakdown and do the division and get to that measurement. I would say no. I would say there's not enough in there because ultimately it's processed seawater. It's not just straight from the ocean. Because if it was, there's not enough in there. We've done tests on it, and the levels are not consistent. So from bottle to bottle, they're not consistent. So you may get a high one, you may get a low one. I mean, if you got a heavy load in there, if you're not testing, if you're just kind of winging it, and I know, hey, I did that for 8-10 years. I just winged it, man. I just dumped stuff in there, and I got pretty lucky for a while, but eventually it catches up with you, and I didn't have the growth that I have now because I wasn't testing, I wasn't dosing properly. But in answer to that question, I would say no. I would say no, it's not. You're going to need to supplement. Now, you might be easier to supplement with liquids because you can get it down to millimeters, like a millimeter cup. Yep, you do that. I would do that. And then get your test kit, man. I mean, I know, you probably noticed I started charging for anything other than your basic parameters. If it's a trace element test, and I'm doing that to encourage you to test, to do this stuff at your house and really see where you're at, because you might only come in, once a month, hey man, can you test my water? That's not telling you anything. It could be low then, and you could dose it, and it goes up for a day or two, and it drops back down because you're only dosing calcium. So, test. You got to test.
Can't make the product. It's 2 parts.
Yep. The AB. The A is the calcium. The B is the alk.
Yep.
What I have found with that, you can do the A full strength. I think I would do the B half because it really shoot your alk up.
Oh yeah.
It's strong, especially in the nano reef, guys. If y'all are doing the nano AB, I would do dose the calcium and dose the alk every other, or do half alk. Do half alk. But it means it's an excellent product because it does both buffering systems. You get both out of it. I mean, here I'm ordering in not super sacks, because that's like